The cross-industry standard process for data mining, or CRISP-DM, is a quantitative method for identifying trends, patterns, and insights in data to help analysts make informed decisions. It's a structured, thorough and validated approach to data mining that's broken down into 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. The first step, business understanding, is really what is the business question or questions the organization is looking to address, and how does the analysis project align itself to succeed in answering the question or questions. The second step, data understanding, is where you start to gather data. You're checking for issues like errors or missing values or inconsistencies. You're doing some exploratory analysis and calculating basic descriptive statistics such as mean, median, or mode. And you're documenting the methods that you're using and any quality issues or potential biases and patterns and characteristics that are important for the analysis, which then leads you to the third step, which is data preparation. And at this point, you're taking the time to select the data you want to work with and clean it. You may need to derive new data if needed to address the business question. So if, for instance, the business question calls for looking for the average amount spent on a good, and that's not available in the data directly, but can be derived from the data, you may be developing a new column that includes that information as part of the analysis. You then move into the modeling phase, which is a combination of logic and algorithms that are applied to the data set, which are influenced by the goals and the nature of the project. So examples of algorithms could be clustering or segmentation, regression, sequencing, classification, and decision trees. At this point, you're working with a prototype model that needs to be tested by another data analyst to ensure that it is consistent with the logic and parameters and to assess its rate of accuracy. From here, you then move into the evaluation step, where the model is being assessed further to determine whether it meets the business goals. So it's being reviewed by a validation team, and feedback is given to determine if the model is sound or it needs further adjustment. There's a thorough review of the process to determine if anything has been overlooked and to assess quality assurance. And then you're going to be preparing a presentation to support a recommendation for or against whether you will deploy this model. And then lastly is deployment. So your model at this point has passed the test. It will deliver results consistent with the business need. So during this process, you're going to continue to monitor the performance of the model and provide periodic reports on performance or any changes or issues with the model. Time series is a set of data points arranged in chronological order, which plotted visually, the user is able to see the direction or trend in the data being measured. So time is therefore the independent variable. Time series forecasting involves making a model based on historical data and extending it outward to predict future values. Before you can forecast time series, you first need to assess what data you have at hand. Is it stationary? Does its statistical attributes such as means and variances stay the same over time? The attributes in turn will lack a specific trend or consistent pattern. If the attributes remain constant, it is easier to make predictions. Conversely, if there's an identifiable trend in one direction, it's non-stationary. Another example is autocorrelation, which occurs when the value of data points is always equal at a given time interval in a repeating systemic pattern, such as residential electricity usage. Another example is seasonality, which refers to fluctuations that occur at periodic intervals regularly, such as increasing sales during the holiday season, followed by declines in the months afterwards. Simple moving average is a forecasting technique for modeling a single variable. You can calculate the average value of a numerical time series over a specific time frame, whether it be number of days, weeks, months, or years. And then the moving average can help to reveal the overall trend as it smooths out the volatility in the data that's being collected. You can also do a weighted moving average, which incorporates the most recent values with more weight than the older values. And this is typically done by multiplying more recent values by a number greater than 1. principles of data ethics include privacy, which consists of individuals having control of their personal data. Maintaining data privacy requires that companies comply with data privacy laws and get consent from individuals before collecting and sharing private information. Another principle is transparency. Individuals should have a clear overview of the data that organizations collect and share. This means that organizations need to be transparent about how they handle and process data, both internally and externally. Along the same lines is accountability. Again, organizations are responsible for the data that they collect, and they must safeguard that private information and should be held accountable if this is not the case. And there certainly have been examples in which there have been financial implications as a way of holding organizations accountable. Lastly, equality, which organizations must be careful not to discriminate against individuals or groups when handling and processing data. One of the ways in which this can be done is, to the extent possible, de-identifying or anonymizing data whenever possible. Machine learning and analysis is only as objective as the humans doing the measuring, observing, and data management. So I would politely ask questions regarding the nature of how the data was measured or observed. I would point out if it appeared that there was a risk that the method employed could contribute to measurement bias. To mitigate the risk of measurement bias, it would be important for the company to utilize multiple methods for measuring. Further, validators should have adequate experience and training. To further mitigate the risk of measurement bias, it's also important to continuously monitor and update scoring and evaluation processes. So, for example, perhaps only consider the majority validator responses to prevent minority responses from skewing the results, or use statistical methods to eliminate outliers in validator responses for the same reason. Regression models are used to measure the relationship between quantitative variables, usually to create a predictive model. Simply put, they show how one variable may affect another in order to make predictions. To look at the relationship between two variables, such as the relationship between air temperature and swimsuit sales, you could create a scatter plot between the two variables to analyze the strength of the relationship. The closer in line the two variables are as their respective values increase or decrease, as well as whether the plot skews upward from left to right, demonstrating a positive relationship, or downwards from left to right, demonstrating a negative relationship, it can be inferred that there is a relationship between the variables. A linear regression line, or R2 value, can further assess the strength of that relationship. So the closer the R2 value is to 1, the stronger the relationship, and conversely, the closer to 0, the weaker the relationship. Classification models, conversely, predict what category an entity will fall into based on a set of predefined features. So, for example, credit models are forecasting tools used to decide whether to lend money to an individual or business and how much they should be willing to risk. Based on factors such as income, down payment, savings, and credit history, banks utilize these and other predefined categories to determine whether to offer you a mortgage and the maximum amount the bank is willing to lend you.